Welcome back to Math 107 College Algebra. In this video, we're going to take a look at some ideas with the graphs of polynomials. So first off, we have the definition of a polynomial. So polynomial function is something of the form f of x equals, and then we have an x to the n plus a sub n minus 1, x to the n minus 1, and we continue in this pattern until we get to a1x, and then a0. So that's what a polynomial looks like. So then we can look at some different terminology. First off, the n that we have here, that's going to be known as the degree. And then we have the idea an x to the n, that's going to be the leading term. Next idea that we have is the number an. That's going to be called the leading coefficient. And in general, all of those a sub whatevers are going to be called coefficients. And then finally, that term a sub 0 is called the constant term. So, next thing we want to look at is, we have this terminology, so now we want to graph a polynomial. So, there's a couple of things we want to look at. First thing we're going to look at is end behavior. And there's four key things we're going to look at. And I did not want to draw that line there. So the first graph we're going to look at is it's going down on the left side and up on the right side. That's going to, and we'll explore this in class, correspond to x. I'm going to write 2k plus 1 to indicate that that's an odd number. And then, as we recall from transformations, if I stick a negative sign in front of that, it's going to look like that. So that'll be your x to the 2k plus 1, but now we're sticking a negative sign in front of it. Then we have the situation that's going up on both ends. So that's going to correspond to something like x to the 2k. And of course, if we put a negative sign in front of that, it flips it upside down. So that corresponds to x to the 2k with the minus sign in front of it. So then the last thing we want to look at is the behavior of the graph at zeros. So there's three key situations here. Multiplicity 1, which we treat as a separate case. Multiplication, or multiplicity even. And multiplicity odd. So if it's a 0 of multiplicity 1, graph's just going to pass straight through the x-axis. Nothing weird going on there. When it's even multiplicity, graph's going to come down, touch the axis, and then come back up. That should actually be touching, unlike what I have drawn there. When the multiplicity is odd in something other than 1, graph's going to flatten out, but still cross the axis. So we have the different things with end behavior that we had, and then also the stuff with multiplicity. So now we can take a look at an example. So I'm going to write this polynomial in factored form. X minus 2 squared times x plus 1 times x minus 1. So this is something of the form x to the 4th and then a bunch of stuff after it. We will see in class that it's going to end up that just the leading term is going to be a factor. So we know the end behavior of this is going to be the function going up on both sides. And then we have a 0 at 2. And that's of multiplicity 2, so the graph's going to touch and then go back up. Also have a 0 at x equals 1. And that's of multiplicity 1, so the graph's going to pass straight through there. And then we have a 0 at negative 1. That's also of multiplicity 1. The graph's going to pass straight through there, and I did not quite draw this to scale. And then eventually go back up. So, that's just an approximation of the graph, what the graph looks like. If I ask you to sketch a graph, big things I'm looking for are, do you know what the end behavior is doing? And do you know what's going on with the zeros? So that'll conclude this video. In the next set of videos, we're going to start some of the preliminary work to actually finding the zeros of a polynomial algebraically.